Everyone. I know folks will be filing in here, so thanks for joining us today for our March Town Hall event on frontline feedback, what works and doesn't in MSD prevention tech. And so as everyone files in today, I'll just kind of do a quick introduction of myself. So my name is Paige DeBelo, and I'm the director of the National Safety Council's MSD Solutions Lab. I'll be our host today, and really thanks everyone for joining us. We have an engaging and informative lineup covering all things MSD prevention technology today, and what we need to consider from the frontline workers' perspective when we're implementing this type of tech, as well as a couple updates to share from the lab. So I'll go ahead and dive right into things. So just to orient us to the town hall today, first I'll provide a bit of introduction here for just a couple more slides, and then I'll be tossing it over to my colleague, Marley Reynoso, to walk us through some research findings and key takeaways from a recent report that was developed by the lab. Then I'll be back to moderate a panel discussion with Ryan Porto, technical specialist in ergonomics at General Motors, Gerardo Ramos, senior staff ergonomist at Tesla, who should be joining us soon. He's having a couple technical difficulties, but we'll hope he's able to pop on, and Craig Morgan, the Safety Dojo lead at the Boeing Company. I'm excited for them to share their experiences involving frontline workers in the selection and process of implementing technology for MSD prevention in their workplaces. So be sure to stick around and hear from them, and you can ask your own questions of that expert panel during that panel portion in just a couple minutes here. And then we'll conclude with just a little bit of information about an upcoming event that we have for the lab. So in case you are new to the MSD Solutions Lab and what we're all about, I thought I would provide just a brief overview. So the National Safety Council launched the MSD Solutions Lab, made possible by generous funding and support from Amazon, almost 5 years ago. And since then, we've been hyper-focused on this mission that you see here on the screen, to eliminate MSDs from workplaces worldwide so that people can spend time doing the things they love with the people they love. And what started as a bold vision to address MSDs, the most common workplace injury, has grown into a dynamic and research-driven movement that's fueled by both innovation and action. The lab offers a wealth of free resources, from white papers to infographics and case studies that are all readily available on our website. We also run two robust grant programs that continue to support and accelerate MSD prevention through a cycle of collaboration and innovation. And we overall just remain committed to raising awareness about both the impact of MSDs and the solutions that are available, and engage the safety community through events like this one. So I'll take just a brief moment to review a couple of the key accomplishments that we've achieved recently, and especially since our last town hall that we had back in the fall. So we published a brief resource on the connection between MSDs and worker well-being, focusing on what frontline workers should know about the connection between their mental and physical health and the likelihood of developing an MSD. We published another short resource also focused on frontline workers, this time about the importance of participatory ergonomics and involving your workers in interventions to prevent MSDs. Our 2026-2027 grant recipients have been selected, and we're currently preparing to announce the funded projects and project teams in the coming months. Our MSD pledge community continues to grow, now with nearly 300 organizations that are committed to creating safer workplaces. Back in January, we launched our fourth annual MSD Solutions Index, which is a survey that organizations can take to assess the maturity of their own MSD prevention efforts. And finally, we're about to publish our next report on frontline workers' perceptions of MSD prevention technology, which brings essential voices into the conversation around using tech to prevent MSDs. And so you can find these resources and a whole lot more on our website at the link that'll be dropped in the chat. So it's been a busy and impactful year for the lab so far, and we're excited to continue building on this momentum. And it's that last topic you see there bolded on the screen, frontline workers' perspectives on tech for MSD prevention, that we'll really be leaning into more today. So we likely know about a lot of these common technologies for MSD prevention already, or at least have some kind of understanding. So we're looking at exoskeletons, cobots, wearable sensors, computer vision technology, and extended, augmented, or virtual reality. So just as a quick overview, exoskeletons are those wearable supports that can reduce the physical load on your muscles and joints during strenuous or repetitive tasks. Cobots are collaborative robots that share work with people and take on some of the high force, repetitive, or awkward tasks to reduce worker strain. We've also got wearable sensors, which are devices that monitor your posture, movement, and other metrics in real time to flag fatigue and reduce injury risk. Computer vision technology is camera-based systems that analyze your posture and movement to detect ergonomic risks and enable early intervention. And then also augmented, virtual, and extended reality, which are a collection of tools for ergonomic training, task guidance, and simulations that can promote safer movements and identify risks in a virtual environment before those injuries might even occur. And so together, these technologies can reduce physical strain, improve ergonomics, and help prevent MSDs by supporting safer work designs and behaviors. However, even though these are becoming increasingly popular for MSD prevention and intervention, frontline workers are not as commonly asked about their perceptions of using these technologies. So do workers think these technologies make them safer? Are they comfortable? Do they see any benefits in them aside from safety? Or might workers actually be apprehensive about using these technologies? And so to understand this more, we ask frontline workers directly, do they see these technologies generally as a burden or as beneficial? And so, Marley, I'll turn it over to you to share more about what we found.
Thank you, Paige, and hi, everyone. Thanks so much for joining today. My name is Marley Reynoso, and I am a Senior Research Associate at the National Safety Council. We're here today to talk about a topic that sits at the intersection of workplace safety and emerging technology, specifically what frontline workers themselves think about the tools that are increasingly being deployed to prevent musculoskeletal disorders. So before we get to the panel discussion, I'm just going to present on some research conducted by the MSD Solutions Lab on the topic. We conducted a survey among 405 non-managerial workers across industries who have experience using wearable sensors, computer vision, exoskeletons, robots or collaborative robots, extended reality or digital twins in their current role. The purpose was to address a key gap in the literature by examining frontline worker experiences with emerging MSD prevention technologies. And this was actually a follow-up to a previous survey the lab conducted among 1,000 frontline workers on their perceptions of their organization's MSD prevention initiatives. A key finding from that survey was that worker comfort and openness to technology was directly correlated with their level of involvement in ergonomic decision-making. So that kind of raised a natural next question, and that's if involvement shapes openness, what do workers actually experience once that technology is deployed? So the survey was designed to answer that by exploring the perspectives of those who either use or are impacted by MSD prevention technologies every day, rather than relying solely on the perspectives of employers or technology developers. The survey covered general MSD risks and symptoms, perceived benefits and concerns about technology, perceived impact on well-being and job satisfaction, and also some themes around participatory ergonomics, which we'll get into later. So before we get into the findings, I just want to briefly orient you to who was in this sample. This was a convenience sample sourced through a third-party survey vendor. Industries with high MSD risk like manufacturing, warehousing, construction, healthcare, and transportation were prioritized during recruitment, which you can see reflected in the top industries graph here on the slide, but participation was not restricted by industry. The gender split was nearly even at 53% male and 47% female. Age-wise, the largest group fell in the 30 to 39 range, with about half of all respondents under 40. On education, the sample ranged widely from high school or less all the way up to bachelor's and graduate degrees. And most respondents had been in their current role between 3 and 9 years. So these are workers with some meaningful on-the-job experience. While the sample reflects diversity across several dimensions, it is worth noting that a little bit over half of the respondents were white and all were English speaking, which is something to keep in mind when considering how broadly these findings apply across the workforce. So now, lastly, before we dive into the findings, I want to share a breakdown of the types of technology used in the sample. To be eligible, respondents had to have personally used at least one MSD prevention technology in their current role. Each respondent was asked to identify the technology they had the most experience with, and while some items were designed to capture general attitudes towards technology, respondents were also asked specifically about the technology they had the most experience with. So looking at the breakdown, wearable sensors were most commonly selected, followed by computer vision. Exoskeletons, extended reality, and cobots were also decently represented. Digital twins had the smallest group with just 14 respondents, so we should be cautious when drawing strong conclusions. We should be cautious about drawing strong conclusions for that category specifically. Additionally, 2 respondents selected other, and specified that their experiences were with automatic patient lifts and ceiling lift or transfer devices. These respondents were included in all overall analyses, but they were excluded from any analyses that compared results across specific technology types. We'll go to the next slide. So we are going to get to the technology perception results here in a minute, but let's take a look at the risk perceptions and MSD burden in this sample. 77% said that they are at least moderately concerned about developing an injury in their current role. 62% agreed their tasks result in physical discomfort, and 64% said their job causes mental stress. Respondents were also asked specifically about MSD signs and symptoms, and were asked if they had experienced pain, tenderness, swelling, redness, burning, cramping, stiffness, loss of strength, reduced range of motion, tingling, or numbness in their current roles. 70% had, and of those, 64% missed work as a result. The most commonly affected body regions are the back, reported by 63% of those with symptoms, followed by the wrists and hands, knees, and shoulders. So this all tells us something important, and that's that these workers are not viewing technology solutions from a neutral starting point. They're already carrying some significant physical and psychological burden, and that context shapes how we should think about technology implementation. So before we get into findings broken down by technology type, I just want to share some more general findings related to technology attitudes. So while you'll see in a few minutes that respondents in this sample viewed MSD prevention technologies generally positively, concerns about technology and artificial intelligence are prevalent. So roughly 46% expressed some concern about data privacy, and about 43% had concerns about AI or technology influencing how they conduct their work. Education was a significant predictor, with more educated workers tending to express stronger concerns on both dimensions. The good news is that 80% said that they were comfortable bringing up technology concerns with their organization's leadership. And that's a really strong predictor of psychological safety, especially when leadership is actually acting on the feedback they receive. And this could also be related to the generally positive perceptions that we see in this sample. For safety professionals, there are some clear implications here. Workers need to know that data collected by technology is going towards safety improvement, not being used to monitor productivity or make disciplinary decisions. Because when technology feels like surveillance, you'll likely lose workers' buy-in and decrease the benefit of the technology. So now we're going to get into various MSD prevention technologies and how they are perceived. So respondents that had experienced MSD signs and symptoms were asked whether they thought the technology increased or decreased MSD signs and symptoms they experienced, or potentially increased in some body parts and decreased in others. The vast majority across all technology types reported that the technology either had no impact, as you can see with the darker green sections in the chart on the left, or decreased MSD signs and symptoms as seen in the lighter green. It makes intuitive sense that these technologies that provide direct physical assistance, like exoskeletons and robots or cobots, were most likely to be perceived as decreasing MSD signs and symptoms, whereas computer vision and wearable sensors were most commonly perceived as having no impact. Wearable sensors and computer vision generate data and raise awareness, but if that data doesn't translate into actual changes to work tasks or environments, workers won't feel a physical difference. And with that being said, respondents did overwhelmingly agree that technologies led to less concern around developing an injury, as seen in the figure on the right, although the pattern regarding physical assistance technologies versus sensing technologies like wearables and computer vision persist. Next slide. So even if sensing technologies don't directly reduce symptoms, they have a meaningful impact in a different dimension, and that's awareness of ergonomic risk factors such as forceful exertions, repetition, and awkward postures. And looking at the awareness chart on the left, 96% of exoskeleton users said that the technology increased their awareness of ergonomic risk factors, and that was the highest of any of the technologies. Wearable sensors came in at second at 91%. Computer vision and extended reality were also strong at 84 and 85%. On the posture side, which you can see in the chart on the right, exoskeletons again led at 81%, reporting improved posture, and wearable sensors were close at 77%. And this is important because awareness and posture correction are foundational to long-term injury prevention. Even technologies that don't immediately reduce symptoms can be building the conditions for safer behavior over time, as long as the people using them understand what the data means and how to act on it. So technology's psychosocial impact can be underappreciated in safety planning and should be considered. When it comes to the technology's impact on mental stress, across all technology types, the majority reported reduced or neutral effects on mental stress. Qualitative responses revealed that the mental stress reduction mechanism varies by technology. For wearable sensors and computer vision, for wearable sensors and computer vision, workers reported that having the technology watch for them reduced anxiety because they didn't have to constantly monitor their own movement patterns. For exoskeletons and robots, the physical relief translated directly into lower cognitive and emotional burden. On job satisfaction, every technology type showed 70% or more of users reporting improvement. And this is a really compelling business case argument. MSD prevention technology doesn't just potentially reduce injuries, it can also demonstrably improve how workers feel about their jobs. So this slide summarizes some standout findings for each technology, and I'll also share some verbatim worker perspectives. So wearable sensors are widely used and drive strong ergonomic awareness. Workers appreciate the monitoring function, with one healthcare worker saying that the sensor tells me where my pain comes from, so I don't need to be stressed about it anymore. However, some noted that the devices can be distracting. Computer vision scores well on awareness and posture, but it is perceived as less effective than other technologies at directly reducing symptoms. Concerns around accuracy and privacy were also noted. Exoskeletons received the most consistently positive feedback of any technology. One manufacturing worker described how the exoskeleton meant, "I don't feel like I'm in immense pain staying in one position." The main challenges were physical discomfort from wearing the device and fit issues. Robots and cobots had the highest rate of symptom reduction and the highest injury concern reduction at 85%. Workers praised reduced physical demands, though some did raise concerns about job security and pace pressure. One respondent stated, "I feel more comfortable and confident in completing my job, which helps alleviate mental stress, but I'm also afraid of eventually being replaced by robots, which increases my mental stress." Extended reality excelled on job satisfaction and stress reduction. Workers described feeling more confident going into physically demanding tasks after simulation training. And like we mentioned, digital twins did have a very small sample, but 93% of that N of 14 reported increased ergonomic awareness, and workers appreciated learning in a simulated environment. One of the most significant findings in this study, and one that has direct implications for how we implement programs, is the role of participatory collaborative environments in technology implementation. Responses on training and involvement data is encouraging overall, with 85% having received adequate training and 83% reporting they had opportunities to practice and provide feedback. But only 53% felt involved in technology decision making. So why does this matter? Because across technology type, worker participation was consistently and significantly correlated with several positive outcomes. Workers who felt comfortable speaking up, who could suggest improvements, and who were involved in decisions reported more positive perceptions of the technology's impact. And that includes more reduced injury concern, greater positive impact on ergonomic awareness, improved posture, improved job satisfaction, and decreased mental stress. However, with all that being said, women were significantly less likely than men to feel involved in technology decision making, 47% versus 58%. So as we design these implementation programs and plans, we need to be deliberate about whose voice is in the room. So based on these findings, there are some key takeaways for safety professionals. The first is to match the technology to the goal. If your objective is to reduce physical load, exoskeletons and cobots are likely your strongest options. If you want to identify and assess risk, wearables and computer vision might be the right tools. And if you're focused on training and proactive design, extended reality or digital twins might be where to invest. So these are really important things to consider because mismatching the tool to objective is a really common and also costly mistake. Second, make sure that you're building trust and not surveillance. Frame every technology program as a benefit to workers. Be explicit and consistent about how data will and will not be used. You can allow opt-out pathways where possible. If workers perceive monitoring technology as punitive, adoption will likely fail or be hindered, and you'll have spent significant resources for a minimal return. Third, and very importantly, is to embed worker voice in adoption. This can mean co-designing pilots with frontline workers. Another idea that we've seen is incorporating participatory ergonomics into technology implementation plans. For example, using technology like sensors and computer vision to validate risk reduction solutions that frontline workers come up with. You can create clear, accessible channels for feedback and make sure to visibly act on it. Make sure that women, frontline workers of color, and newer employees are actively included in selection and evaluation processes, not just managers and senior workers. And then the last one that I'll mention is to measure well-being as a return on investment. Job satisfaction, mental stress reduction, and perceived physical relief are legitimate return on investment metrics for safety technology. They tie directly to retention, productivity, and long-term program sustainability. So if your current ROI model only tracks injury rates and lost time, you could be leaving out some critical information. So looking ahead, this study points to several directions for future research. First, we need technology-specific study designs with measures tailored to each tool. While this standardized survey was very useful to glean some general insights on perception, it did employ a general set of questions that were applied uniformly across all technology types, despite meaningful differences in how each technology functions and is used in practice. So as a result, some important nuances specific to particular technologies may not have been fully captured. Future studies should also provide some clear, context-specific descriptions of the technology types, and they should also recruit from organizations where technology use is verified, and they should make sure to include diverse and representative participant groups. Future studies should also collect longitudinal data to see whether these positive perceptions hold over time. And finally, the gender gap that we saw in decision-making participation is a meaningful signal. So understanding why that gap exists, exploring other potential gaps and how that plays out and how those gaps play out across different technologies is a really important avenue for further investigation. So that ends my time today. Like Paige mentioned earlier, a full report on these findings will be released very soon, hopefully in the next week or so. So I encourage you all to check that out on our resources page, which you can access here with the QR code. I also wanted to mention and encourage you all to check out a new resource that the lab put out about participatory ergonomics. It includes some real industry examples of how organizations are involving their frontline workers and operators in technology implementation for MSD risk reduction. So with that, I will pass it back to Paige so we can get started with the panel discussion.
Yeah, thanks so much, Marley, for those great insights on frontline worker perceptions of different tech for MSD prevention. I think that's super helpful for our audience to get just kind of a little taste of what's going to be in that report coming out, like you said, in just the next couple of weeks. So thanks so much. And now we're going to turn it over and be joined by our expert panel to provide even more color to this conversation and give their really firsthand and lived experience of working with frontline workers and involving them in MSD prevention technology use. So panelists, welcome. And so
Thank
we
you.
really appreciate you being here today, Ryan and Craig. And so let's maybe start with some quick introductions before jumping into the panel discussion. And so, Craig, I'll start with you if you want to share a bit about maybe who you are, where you work, what you do, and maybe how you got into workplace health and safety. And I think folks might also be interested to know what technologies you guys are currently using over at the Boeing company. So, Craig, I'll turn it over for you.
Okay, can you hear me okay?
Yeah, we got
All right.
you. Mhm.
My name's Craig Morgan. I've worked for the Boeing Company for 37 years now. I started my career as a structures mechanic on the 747. I was also a door mechanic on the 767 and the 777. And being a frontline worker myself and building these awesome airplanes that we do, I ended up having 8 surgeries to my body. Um, Carpal tunnel on both hands. I broke my back on the 47. I'm not even going to start talking about my ankle surgeries. But fortunately, I was able to get off of the production line and started a room at the Boeing Everett site called the Safety Dojo. And in the Safety Dojo, we help frontline workers with ergonomics and tool development so we can build our airplane safer and everybody goes home safe every day. Uh, Now we have safety dojos across the Boeing enterprise, helping more of our frontline workers go home safe each and every day. I guess you could say I've got skin in the game because I'm on the factory floor every day with our mechanics, helping walk the airplanes and build the airplanes for new technology when it comes to our tools and our processes of building the airplanes.
Thanks so much, Craig. And over to you, Ryan, for our intro.
Yeah, my name is Ryan Porto. I am a technical specialist in manufacturing ergonomics at General Motors. I work in our workplace safety group. Um, I've been with the company for about 20 years, started off in program ergonomics, where we're looking at a vehicle of the future that's going to go in to a certain site or a factory. My specialty was actually digital human modeling and human motion capture. So started an ergonomics lab with that. I've since transitioned into this new technologies, so Vet for Ergo, so evaluating them, implementing them, and I think it's a pretty exciting time when you think about all the stuff that's coming at us. There's a lot, but again, I think it's really exciting to look at this stuff and incorporate them into our rules.
Yeah, thanks so much for that, Ryan. And we think it's an exciting time too. And I think conversations like this will hopefully help folks as they try to navigate deciding what MSD prevention tech might fit for them, what to consider from that frontline worker side too. So we want to make sure we're implementing tools that really feel comfortable and usable to our workers. So we'll
Yeah.
definitely dive into some of that today. And we do have, I'll just mention kind of for the structure of this portion, but we have some questions to get through on our side for the panelists today. But please, for those in the audience, feel free to use the Q&A function that you should see at the bottom of your screen. You can drop your questions in there and we'll be monitoring that in real time. And we'll try to get to your questions as time permits throughout the panel portion today. But if not, we can try to follow up with you guys after the event today as well. Especially if you let us see what your name is within the Q&A portion, we can get back to you. So we'll dive in with some of our canned questions here, but again, feel free to drop any of your questions in the Q&A as they pop into your brain. So Ryan, I'm going to go ahead and start with you to kick us off. So your workers at GM likely interact with a wide range of risk assessments and technologies. And so when you're introducing new MSD prevention technologies, what have you seen most strongly influence worker acceptance?
Yeah, so we'll start when we kind of bring in a new technology or we're investigating one. We'll take a look at the research, and oftentimes it may not fit what we're looking at, the task of what we're looking at in automotive. So we're not going out and doing a research project on every technology, but we like to go out and just make sure it's going to kind of canvas our jobs and then make sure it's going to fit. Is the wearable, if, for example, if it is a wearable, is it going to fit our task? From that, we really provide, we go from there with just providing good education and awareness of the risks that we're tackling and the risk factors and the benefits to the workers. I think this really needs a lot of improvements because it's just not, it's something they can't find on, say, social media very easily, right? They're not on LinkedIn, the typical operator. So it's important that we have that kind of checked and we can bring that information to them and communicate to them on a regular basis. So very important for user acceptance, I would say. And then that regular follow up. So constantly checking in on them if we are going to deploy like any type of wearable or even use some of the newer risk analysis tools. that regular follow-up, whether it be questionnaire-based or just personally checking in on them, and getting their feedback and updating the team as we go forward and implement more and more devices or technology in that area.
Yeah, thanks so much for that, Ryan. I think a couple really useful nuggets. I think you talked about making sure you're matching your risk types to the tech that you're deploying. I think that can be kind of a baseline thing that folks need to be considering is we don't just maybe want to pull something because it seems bright and shiny and try to implement it into our work sites. We really need to make sure that the technology that we're selecting actually fits with the risk that we have, which sounds pretty basic, but I think sometimes we just get excited about all this new tech that's coming out and might skip that step.
Right, right. Yeah, the vendors and the, inventors, they're trying to serve a wide variety of industries, right? So it may
Yeah.
not always work for like automotive. So we just kind of do some pre-testing and sometimes some research in that area, which ends up being pretty good for us.
Yeah, yep, that seems great. That sounds like a great kind of process to follow. And I also like what you said about those frequent check-ins. So making sure that you get feedback from your employees kind of throughout the process to make sure that they're still feeling okay about it. Because maybe at the peak of implementing something, they're super psyched, they see that it's working, but then over time they recognize a couple other kind of kinks in the system. So I like that. It sounds like you guys have like a regular cadence for conducting that follow-up. So it's great.
Exactly.
Thanks for sharing, Ryan. And Craig, I'll bring it over to you for this next question. So like you mentioned, you're, kind of in a position where you might be able to interact with frontline workers every day, just based on, your job role. So could you share an example where frontline worker feedback directly changed how you deployed an MSD prevention technology, or even whether you continued using the technology at all?
Yes. Obviously, building large airplanes, the tubes come together separately, and we have to join the large tubes of the airplane together, of like the tail to the middle to the wings. And for years, we've been doing this with mechanics going over the curvature of the airplane, doing all the drilling, the filling. When I say filling, I mean putting seal in each hole, and then putting a fastener in it. Um, and by doing this, we're using drills, we're using seal guns, and we're using rivet guns that have a lot of heavy impact and high vibratory, which is not good for the mechanic's hands. We've been doing it like that for years, and then recently we have gotten into the technology of a cobot, which has a suction cup that goes around the circumference of the airplane, and that suction cup holds a track, and on the track there's a computer with the drills and the seal and the fasteners in it. So now instead of our mechanics having to do all that heavy work, we have the cobot doing the work for us. But um, there was a lot to go into it. We had the contractors come out that own the cobots, and our mechanics had to talk with them about the different fasteners, of the lengths of the fasteners that had to go into the airplane. And of course, like you mentioned earlier, Marley, about um, the mechanics were a little worried about their keeping their job, right? They didn't want to lose their job to a cobot and a robot. So what we did was we trained those mechanics in using that machinery. So now they do all the maintenance on those cobots and robots, which has allowed them to keep their jobs. And it's also what the big factor is. It's extending their careers because they go home feeling better each and every day. But we're also not having a lot of those hand surgeries that we used to have: hand, elbow, shoulder. So yeah, it's extending our mechanics' careers, and it was a big turnaround, and now they're super happy about it. They even named some of them. So yeah,
Yeah.
the technology is so much different. The innovation that we're doing here, and with that comes we can build the airplane a little bit faster also. So it helps with safety, quality, and the productivity.
Yeah, thanks for sharing that, Craig. I think that I love the example, and I don't think we hear a whole lot of cobot examples, and so I appreciate that, especially from the perspective of, like you mentioned, some of what Marley shared is might be some concerns about job security when it comes to that, and so making sure you have kind of clear communication. We'll get to some communication pieces later in our questions, but I think having that up front with workers can really help to make their acceptance of tech use for this kind of thing a little bit more positive. So thanks for sharing that. Really appreciate it. And so, Ryan, kind of bringing this similar question over to you. So, what about at GM? When has worker feedback directly changed how you guys deployed MSD prevention technology? Or maybe if you even considered kind of scrapping the deployment of MSD prevention tech?
Yeah, it's critical. I think we took a lot of lessons learned from a deployment. I'll give an example of the upper arm assist exoskeleton, which kind of came out pretty fast and furious. At the time, General Motors was focusing on a powered hand grasp just to cover distal upper extremity issues, the iron hand actually. So, but the upper arm came up and, it could really target those overhead jobs for us, which we have, quite a few, quite a few issues on. So, I think just what I talked about before, kind of doing due diligence and making sure it fits the job. Um, and it's okay to, try and fail fast. I think you don't want to not do a deployment because it's scary. But we learned a lot about the shoulder device, and when the back exoskeleton, kind of like the soft exosuits, kind of came into play,
Mhm.
and they became more readily available, widespread in the market. We put together just a much better deployment plan from listening to operators, from gathering questionnaires from the first one. That pre-work to do what jobs are the best suited for them, the job identification, not just trying it on everyone and everywhere. Learned about training, selecting one vendor and a few plants as opposed to trying to do it corporation wide. So really targeting jobs, really targeting sites. And then those regular check-ins again are so important. And I think that really changed how we did deployment, just gathering, that documentation and feedback from the workers and learning from the first one. So we get better and better every, every time.
Yeah, thanks for that. Yeah, I like the idea of kind of maybe using some of your own sites to pilot before maybe you try to go enterprise wide with something and learning from those pilots, even not just to inform the same type of technology, implementation in the future, but you could use, a wearable implementation to inform how you might do an exoskeleton implementation in the future, which I think it's good to see where those kind of cross learnings can happen there. So appreciate that. And maybe sticking with you, Ryan, and kind of in the same vein of different types of technology, that you guys might have implemented and how folks might respond to that. Like Marley mentioned, workers might have, different feedback depending on what the tech is that they're being asked to utilize. So given that, have you seen any differences in how workers react to wearables or exoskeletons, computer vision, sensor-based tools, things you guys have tried? And are there any patterns that stand out in that?
Yeah. I guess I'd start with just like for exoskeletons, like a wearable, the larger ones you're wearing, we get pretty direct, immediate feedback from someone like wearing an exoskeleton. Usually, it takes for the wearable sensors. Usually, you're looking at a few days, maybe about a week. But I find like that data has to be really easily accessible to them. So they have to be able to understand it. And I really think for the wearable sensor type task, you need pretty good like baseline data. And we found that you kind of need that job coach to follow up with them. Okay, this is what you were doing. This is how you can correct it, right? Because it's not always, it's time sensitive to go read the data, whether it's on their phone or on a tablet or on a main screen in the plant. So I think a wearable takes a little longer, wearable sensor, like a wearable sensor device, little longer to get like feedback on and to understand. They're not all like an Apple Watch yet, right? They're not as user friendly. For data, like just actually doing for a data acquisition, say something like computer vision, for example, like filming, recording, things like that. We have a pretty good relationship with our leadership and our unionized workers. So anything we bring to the floor, like ahead of time, it's pretty well meticulously analyzed from a privacy standpoint. And then we provide like awareness from leadership, and we cascade that down to all the entire site. What patterns stand out? I think for the computer vision and AI, people want to know kind of like the end game for that. I mentioned about wearables and exoskeletons, not as much. Um, available to them to go research online, but there sure is a lot in on AI. So tons in the media, tons online. So it's critical that like those pilots are, the whys and of why we're doing them and what we intend to get out of them, and we share that with the workers. So that's probably the
Hey,
three, key differences I'd say between those types of.
Paige, can I add something with that?
Yeah, yeah, go ahead, Craig.
What we have noticed is kind of like a generational shift of we've hired so many new employees here at the Everett site. I've spoken to over 15,000 new employees in the last 4 years. And when I'm out on the airplane, showing off new tools and things like that, the generational shift is the younger generation seems to want to use the exoskeletons more, whereas the older, crustier guy mechanic like me, we get the response of I've been doing it like this for 30 years. Don't tell me what I need, and then so it just takes a little more education and training with them until uh, they come around to, wow, I'm going home. I feel better each and every day that I use this exoskeleton. So the mindset has been switched, but it has been what I have noticed is a generational thing.
Yeah, we have about a mix there, I would say. Definitely see that a lot, Greg. But I still think there's a bit of a mix for us on the younger or more veteran worker.
Yeah, thanks for sharing those insights. I think that's an interesting concept, but I know Marley touched on some like individual differences and how folks are, perceiving technology. But I think that generational piece is really important to get at, and interesting that you guys have seen patterns in that regard, especially for you, Craig, maybe at Boeing, and Ryan, how you guys see that a little bit too, and just how to maybe even tailor the communication that you might need to have to your employees depending on some of the demographic, buckets that they might fit in. So
Yeah.
appreciate you sharing that insight too, Craig. And Craig, I'll stick with you. And so a little bit, you talked about, maybe exoskeletons aren't landing as well with some of your older workers. And so when a technology doesn't land well with workers, what are some of the early warning signs that you notice on the floor? And then maybe how do you try to circumvent those?
Well, first of all, it depends on if the what type of technology or tool it is. If it's a tool
Mhm.
that doesn't need to be used to complete the job, the warning sign is that they don't use the tool to complete the job. Another one, which is very negative, but another warning sign is that the new tool gets broken right away. Funny how that could happen, right? And then also, if the new tool doesn't land well with the mechanics, the job count could go up, and it could be blamed on the tool that it's too slow. Um, so I've seen all of these happen before. The new technology is released to the shop floor training. The most important is that the proof that the technology it's in everyone's best interest. Once you can prove that, the mechanics seem to come around to want to use it more. But that's what we're finding.
Yeah,
Sorry,
yeah.
sorry about the negative part about the broken tool right away, but that's just the truth. I've seen it happen. Um, and then once the teams start working together and see how that new technology is really helping them with the quality and the productivity, that's where it starts to be used more.
Yeah. And it seems like you guys, I mean, I know that, a tool being broken or some of those type of metrics is maybe hard to swallow, but at least you have some clear early warning signs, right? You're not trying to maybe weed through and understand if folks like this, do they not like this? Like you can see, it sounds like pretty quickly if something is landing well or not, which I think even if the data feel a little bit strong, at least you know that it might be time to sunset something or make a change. So that seems like it could be helpful.
Yeah,
Yeah, important to think about, when it's time to stop the pilot or how to recognize it. Maybe it's just not the right fit. So appreciate you sharing those, insights from Boeing. And Ryan, I'll move over to you for this next question. So kind of the inverse approach to this. But what about the positive aspects you hear from frontline workers? So what benefits do you hear, directly from workers at GM after they've used these technologies? Maybe they think it's really easy to use. They, notice that it reduces their discomfort levels, makes their job easier, helps them to know if their body's hurting. What kind of things are you seeing in the positive realm?
Yeah, I think ultimately it's all about that probably over days or weekly fatigue reduction. So mainly that comfort reduction for most operators, whether they get it's something that's going to be immediate that I'm putting on and I'm going to feel it right away, hopefully, if it's working for them, or that long-standing. Okay, we got to do a little bit. We got to do some computer vision. We got to show it to you, record the task and show you, or maybe wearable sensor where it comes down to training. So I think one of the main things is as long as they are involved, right? We have really good success when they make them feel empowered, right? So they're involved in trying the new technology. A lot of the times they think it's so cool. If we're recording someone, sometimes we get volunteers like, hey, I want to be recorded, right? Like, kind of show me. So I think as far as right, there's the immediate ones where it's a wearable. Some of the wearable sensors takes a little bit longer to kind of see that benefit and then get their feedback. But most of our pilots, like most of the time, even the early pilots include all of the workers, right? And we're getting their feedback. But going back to kind of like the recording or the wearable sensors, the job training is big, I think, where they can see maybe they're doing something wrong and they can get like immediate feedback, or we can record for comparison's sake. This is a more experienced worker doing it to somebody starting on like their first day. So we get to look at shift comparisons or site comparisons and lessons learned across sites. Some people have great ergonomic suggestions that can now that we can share and see others, what others are doing, right? Not to compare everyone to everybody else, but it helps. So people want to see what could I do better. So for that type of technology, I think that could serve us well in the future.
Yeah, I think that's great. I appreciate that you touched on the fatigues. I think that's one of the things that maybe workers will see, most quickly is, exoskeletons making their body feel less worn down, or the wearables, indicating to them that they've been in awkward posture for too long, so they ought to change their position. So I think that's really palatable, and tangible for a frontline worker to kind of cling on to. But also some of the other things you mentioned, like the data can be used for training. Maybe you have exemplars who are doing work in, a really safe way that you might want to be able to show easier to other workers. So appreciate that. And so, Craig, I'll bring it to you. I know we've talked a little bit about communication and education awareness, but we know that a lot of times, how a new technology is communicated to workers might be the key to them viewing it positively and being more likely to see some of those benefits from it. And Marley also shared earlier, our survey found that trust and transparency in how we're talking about these technologies can significantly shape worker attitudes. So, what are some communication strategies that have been most effective in building trust around new tech at Boeing?
Yeah, TNT, trust and transparency. That's the key factor here. And our safety dojo plays a key role. In the safety dojo, we have a lot of new innovative tools where our frontline workers know they can come in here, and we have over 100 years of experience in the safety dojo. So they know they can trust us. And not only can they come in by themselves, but we also hold team meetings when a new tool comes out, and we can bring the whole team in here, not only to test the tool, but we can also check it out to them so they can go out to their area and use it. But we have testing centers here where we don't just give somebody a new tool and say go use it on the airplane. It takes a lot of time to learn more about the new tool for quality measures. So it seems to work better when it's one-on-one sometimes, other than large groups, for the mechanics to feel more comfortable with it. Another communication strategy for us is our safety dojo. We also have a trailer, and so our campus is so large, not everybody can come to the safety dojo for these meetings. So we have the safety dojo on the go. If we can go actually to their sites. So right now we have these safety dojos traveling around all the Boeing enterprise all across the country, showing off the new technology, so more and more people can get their hands on it.
Well, thanks. I think it sounds like those testing sites that you have, Craig, are pretty low risk for folks too. Like just kind of go out and try this, and if it works, it works, and if it doesn't, it doesn't. And I think even just kind of the ability for the tech to not be the right fit is comforting for folks to know that kind of from the get-go. It's not something that's going to be forced upon them, maybe. So
I
appreciate
just
that.
always I just always find that hands-on is the best communication you can have.
Yeah. Yeah.
And repetitive training with it always
Hmm.
helps out also.
Yeah. Yep. Appreciate that. And I wanted to ask another question that kind of wasn't in our lineup today, but I'm seeing come through is, maybe from pilot, and this, can be for Craig or from Ryan, excuse me, but from pilot to implementation, what's the typical duration that you see when you're kind of trying to communicate this out to employees, get their buy-in, and then get something going in the field? Is there kind of a typical runway time that you give for implementing a new technology?
I mean, it really depends on the technology. I think for something wearable, it goes a lot quicker. Anytime like something physical that we can put on the worker and they can try it right away, kind of like Greg's doing early on with the safety dojo, and you could come in and try stuff, different types of equipment. The stuff where that involves software, as you could guess, a little, we have to check all of that and understand what types of devices it's going to go on, and it goes. I mean, we have a pretty robust process for it, but it takes time to like kind of set up that pilot and understand what we're going to do with all the data, because there's just so much data. There's a lot of oftentimes we'll have the supplier involved, or we will leverage academia and use a university student to help us understand, because it's just our ergonomists, that's not in like their daily tasks. Their daily tasks are to help operators and fix jobs. So that takes a little longer, I would say, to set up. I would say maybe it's in the 3 to 4 month range. Anytime we're looking at like a sensor or any type of computer vision.
Thanks for
Yeah,
that.
for us, I would just say we're all over the board with that, right? Some technology it takes us years to get implemented, uh, but others we're allowed to go outside. We do a lot of tool development, but we're also allowed to go outside of the company to make purchases. And one example is that is a new ergo chair called the Human Hoist, where it'll take you from a chair sitting down all the way to like a creeper of a garage. And that allows our mechanics that work not only on the airplane, but also in propulsions up underneath the engines. It allows us to get them in the correct strike zone. So when they're doing their work, they're not on their hands and knees working above their head. They're in a nice chair that can be positioned to where they need it. So yeah, sometimes it takes years to get something implemented, and sometimes we can buy something right off the shelf and bring it in here and make an immediate impact.
Yeah. I appreciate you guys sharing that. I think, the answer, it depends, is maybe applicable here. And, also I like Brian, you mentioned that 3 to 4 month range. Just so that folks know, especially, listening, like, especially if you're in a small business or maybe just dabbling in utilizing technology, it might take a little bit of time to get something implemented, especially if you're going to, seek that frontline worker feedback and make sure it fits with their needs. So,
Well, and replication plays a big part in it too. We've noticed, we're doing something over here on the 777 production line, and the 767's 100 yards away, and they don't know about it. So
mm,
sometimes we have this new technology and we don't share it enough, and so that's one of my main jobs is replication and getting it out and sharing it with more teams.
yeah. I appreciate that, Craig. I think, yeah, I mean, it doubles down on that communication piece too, being so key that if you find something that's working over here, make sure that can be disseminated throughout your organization. And I think, maybe bringing it back to, one of the charges of the lab is to understand some of those things that are working, even at specific sites or in specific companies, and try to, as much as folks are willing to share that out with the broader community who's trying to tackle some of these, MSD issues that they have in their workplaces so that they can know what are the suitable solutions that might be available to them. So appreciate you mentioning that. And maybe just to wrap up our time, Craig, I'll stick with you. Kind of a looking ahead type of question. But what MSD prevention technologies do you think workers are most likely to embrace kind of moving forward, or makes solutions feel maybe more worker friendly than others?
At the moment, I believe I would say wearables and sensors for high vibratory tools. Um, Building these huge fuselages, we use a lot of tools that vibrate, like the rivet guns and the palm sanders, and we have a lot of hand injuries and a lot of complaining about hands hurting. And um, just recently, I traveled to Boeing Wichita, where we just bought the Spirit Aerospace factory, and it's funny how the things that we have here in Everett, they don't have at other sites, and that so we're really using a lot of wearable sensors so we can gauge that vibration, and we're coming up with new technology of they're called mass enhanced rivet guns, where the barrel of the rivet gun um, is circled with tungsten shot or steel shot, and that it's like little BBs wrapped around the gun. And with that, it creates a frequency where the vibration doesn't go into the human body from doing the work. So that's what we're really focusing on right now is vibratory tools to help our mechanics.
Yeah, thanks for sharing that, Craig. And what about for you, Ryan? Any maybe last tidbits to share with the audience, or where you see kind of safety tech moving in the future?
Yeah. I think for the wearables, I'd agree with Greg. We kind of have non-standard tasks that pop up all the time where it's, what I mean by that is like non-cyclic or something totally new, or just not so repetitive. Like a worker could be working at our test track and they got to change a bunch of tires, and there's not like a hoist or any real lift assist to help them do that sort of thing. But as we look at kind of the other ones, as far as looking at the immersive stuff, VR or computer vision, it helps us, I think, also get like organized in the future. So looking at tasks today, and then looking on the vehicles we build today, and then looking at tasks in the future. So how can we balance jobs better? How can we make training better? How I alluded to before. So things like that, I think, on the technology with the software end, can really help us as like the engineering community get better organized to even to set up jobs so we can eliminate injuries.
So Ryan, you mentioned earlier you have an ergo lab.
Yes, there's a few.
So yeah, so I would be really interested in checking that out one day, and then maybe you can come to the safety dojo and we can share some ideas that will help both of us.
That would be awesome if we can do it. Let's talk.
Yeah,
Yeah,
that'd
I
be
love
great.
that. Yeah, we like to see the collaboration. I appreciate that, and I think that is a good connection point there. And so I know we just have like a couple more minutes, but we did get a question through that I want to maybe get to if we can. And I think I know the answer to this, but what maybe is the estimate cost for some of these ergo techs that we're mentioning for folks in the audience that are interested in deploying?
Yep, that's another one. It depends.
Hmm.
Wearables can go anywhere from, maybe I've seen some for $800-900, to where and then if you have to sign up to a subscription to something, I mean, it really depends on the size of your corporation, sometimes how many jobs you're going to evaluate, right? All that sort of thing.
Yeah,
So yeah, it really depends on what you're looking at.
yeah. Thanks,
And
Ryan.
the cost factor here is yes, we spend $22,000 on a ergo chair, but that prevents a back injury that could be $400,000 or $500,000, and then have that mechanic out of work for 6 months. So by purchasing and bringing in the new technology, we're actually saving money and getting ahead of the game.
Yeah.
Absolutely.
Yep. Yep. Good to look at it from that ROI perspective. Well, thanks so much, you guys. I really appreciate your time today. I know we just have about 1 minute to wrap up, but Ryan and Craig, thanks so much for taking us through that panel. And I'll just share about an upcoming event that we have in the MSD Solutions Lab, and then we'll break for the day. So thanks again, Ryan and Craig. So
Thank
the
you.
MSD Solutions Lab is going to be hosting a workshop at an upcoming NSC Safety Summit in May. So I encourage you to make some plans to register if you haven't already. for that event. And we also will have a workshop at that event that I hope that you can register for as well. And I think if we can go to the next slide there, we should be able to see a little bit about that event. There we go. And so we'll have a couple experts from the National Safety Council, Cargill, John Deere, Work Care there to lead us through a workshop on making sense of MSD prevention tech. So if you enjoyed today's session, you're likely to enjoy this session at the Safety Summit as well. So we encourage you to register for the Safety Summit and also register for that workshop if that's something you'd like to learn more about. And there are CEUs that you can get as well from attending the workshop. And so we have a couple links that we can drop to those in the chat. But really just thank you all again for being part of this movement. Whether you're a part of the MSD Pledge community or not, we really appreciate everyone kind of coming together to try to prevent the most common workplace injury. So we'll continue to send our frontline worker voices in these efforts as we establish effective interventions. And so just really thanks everyone for being with us today and be safe.